students, now I am taking a new chapter, number 17. This is the semiconductor devices. Semiconductors or electronics is given another name. Electronics. Generally, there is a question that what the difference between the electrical and electronics. This is asked by many of the people. So, electrical means the devices in which the semiconductors are not used and they are simply based on the current, like your electric bulb, electric tube lights, electric heater, and the electric toaster, electric press. All these are the electricals. Electronic devices are those in which the semiconducting devices are used, like your mobile, LED TV, computer, and all kinds of this devices are called the electronic devices. So they are based on the semiconductor devices. And while discussing through this chapter, first I will like to tell you about the energy bands in solids. This is very essential because all this is based upon the band theory of solids. Energy bands. In solids. As you know that the atom have the nucleus and there are electrons which are moving around the nucleus. In the electron are arranged in the discrete energy levels like K, L, M, N, and further they follow the Pauli-Exclusion principle, so they are arranged in the orbitals, and following the Pauli-Exclusion principle, no two electrons can have the same quantum number, so they are arranged in such a way that Pauli-Exclusion principle is followed in the electronic configuration. So first I will tell you that what happens when the two atoms are brought together. This I will show you by diagram. Suppose here I have the interatomic distance, on this part. Here we have energy. Better is that I take it. Here. This is your S. This is P. S and P. These are the subsets. This is the interatomic spacing. Suppose this is now A, and when these are brought together, they start to overlap. So as a result, and here, and then so this is the region. Then we will have this A to be like this. So here we have this point corresponds to this one, then this point where this line intersects. Then we are having this, and then here, now here this is your band gap. This is conduction band. And this is balance band. Balance band. So here we have suppose these are the energy levels. Like this, and the difference between these two is very small, approximately 10 raised to the power minus 22 electron volt. So this I am showing the bands are composed of closely spaced orbitals. So this is the structure that shows the formation of the conduction band and the valence band, and the gap between these two is called the band gap, or this is also called the Faraday energy gap. A single isolated atom have electron orbitals of discrete energy levels. When two atoms two identical atoms are brought together to form a molecule. Their atomic orbitals overlay. Following Pauli exclusion principle. Principle. When two identical atoms are combined, when two identical atoms are combined to form diatomic molecule. Diatomic molecule. Each atomic orbital splits into two molecular orbits, into two molecular orbits. Orbitals of different energy. Different energy. Along the electron, electrons in formal atomic orbitals to occupy the new orbitals structure without any having same energy. It means that when the two identical atoms are brought together to form a single molecule, then their orbital is split. Then definitely the electron which are present in the former atom, the former orbitals, they have to occupy the new orbitals. And this must be in such a way that Pauli exclusion principle should not be violated. So the electron have to occupy the new orbitals without any having the same energy. The energy will be different because now we have the new orbital. So definitely the energy of these orbitals will be different from those which were in the former state or in the initial state. It is shown in figure. Similarly, if a large number of identical atoms come together to form a solid, the atomic orbitals overlap. Suppose number of atoms equal to n, and this is, we take 10 raised to the power 22. That is 1 mole of substance, we can take it. So due to overlapping, each atomic orbital bit will split in n orbitals. Discrete molecular orbitals, each with a different energy. Of 10 raised to the power minus 22 electron volt. What we have said, that suppose there are n orbitals, then we suppose that the energy of the orbital is 1 electron volt, and if there are so many atoms, then when they split, then the energy of each orbital will be 1 upon 10 raised to the power 22 electron volt. So this is 10 raised to the power minus 22 electron volt, and you can find that this energy is very less. So this is what we have said here, that due to overlapping, each atomic orbital will split in n discrete molecular orbitals, each with a different energy of 10 raised to the power minus 22 electron volt. The energy of adjacent levels is so close together that they can be considered as a continuum. Continue. The energy bands. So energy bands is what? That when we have so much difference of the orbitals, there are a number of orbitals which are a continuous series of these orbitals. This continuous series of the orbitals is called the energy band. Thus formation of band. Is a feature of outermost electrons. It means that the band formation takes place in the energy levels which are outermost, and the innermost remain approximately the constant, the same. The inner electron orbital do not overlap significantly. Do not overlap significantly. So their bands are narrow. It means that the inner orbitals remain unaffected, approximate. They are less affected by the in the crystal. Two bands are formed. Number one, conduction band. And number two, valence band. Valence band. Band gap are essential. Band gap are essential, which depend upon degree of overlapping. Degree of overlapping. Overlapping in atomic orbitals from which they arise. The band gap conduction and valence bands is called forbidden energy gap. Energy level, forbidden energy gap. Energy gap. So the gap between the two depends upon the degree of overlapping in atomic orbitals. Depends upon the nature of the crystal. It means it depends upon the nature of crystal. Thus, band gap upon nature of solid. It means that band gap is different in the different solids. If they are of different kinds, suppose some are the conductors, some are non-conductors, some are insulators, then definitely they will have the different energy levels, different band gaps. At room temperature. Some electrons go to conduction band due to thermal energy. So this is what we have taken the formation of energy bands. But formation of this energy band is based on certain assumptions. Basic assumptions of band theory. Band theory is only an approximation to quantum states. State of solid. Consisting a large number of identical atoms. So following assumptions are necessary. necessary. Now there are three assumptions while discussing to this. Number one, infinite site system. It means that we consider infinite number of molecules for bands to be continuous. Uh, there must be large number of identical atoms in a solid. Number second, homogeneous system. Band structure is an intrinsic property of a material which assumes that material is homogeneous. Which assumes that material is homogeneous. It means that there is no other type of atoms, there are only single type of atom only. Suppose we take for example the iron, then there must be the iron atoms. If we take aluminum, then there must be the aluminum atoms. No other atom must be there except one kind of nature. So this is what the homogeneous system. And the third assumption is non-interactivity. Non-interactivity. The band structure describes single electron states. Single electron state. Which assumes that electron travel electrons travel in a static potential static potential without dynamically dynamically interacting with lattice vibrations other electrons photons, etc. So these are the assumptions on which the band theory is based. So if these are followed, then there are the formation of energy bands in the solids. So this is what I told you, that when the atoms are far away from each other, then they are having the discrete energy levels, and when they are brought together at a distance of interatomic spacing, then there is an overlapping of the electron orbitals in such a way that when the new orbitals are formed, the electron formerly present will occupy the new orbitals following the Pauli exclusion principle, and then the energy orbitals are very closely spaced. So there is a continuum, you can say that there is a continuous energy orbitals, that is called the energy band. So depending upon the nature, the energy bands are of two kinds: the conduction band and the valence band. In valence band, there are the valence electrons, which are involved in the chemical and physical properties, and when they are getting some energy at the room temperature, they are excited to the conduction band, where they are responsible for the electrical conductivity. But as such, this is based on the certain assumptions that a crystal is homogeneous and it has a large number of molecules, and the orbitals, the electrons in the orbitals do not interact with the other electrons and the photons and the lattice vibrations. So this is what the formation of the energy bands. So you like, share and subscribe this video. Thank you.